Hi everyone, hope you're doing well. I'm Reza, founder of the OptimizationCity.com. In this film, we are talking about the sensitivity analysis of the objective function in the linear programming. Let's go on.
In this part, we are trying to delve with the sensitive analysis of the objective function coefficient. Modifying the coefficient of the objective function impact the slope of the objective function line. If this modification exceeds a certain threshold, it can lead to a change in the optimal point. Consequently, a set of critical constraints and the type of resource, whether they are scarce or redundant, can be affected. The objective sensitive analysis seeks to address the following question: how much coefficient of the objective function can be changed, increased, or decreased without changing the optimal solution? In the previous example, let's denote the coefficient of the objective function as C1 and C2. The objective function can be expressed as follows: z is equal to C1t times x1 plus C2 x2. As depicted in the diagram below, when C1 increase and C2 decrease, the objective function line rotate clockwise around point C. Conversely, as C1 as a decrease in C1 or an increase in C2 cause Z to move counterclockwise. Therefore, point C remain optimal until the slope of the objective function Z lie between the slope of the constraint 1 and constraint 2. If the slope of the line with the slope of first constraint, the problem will have the two optimal kernel point, which is C and D here. Similarly, when the slope of Z coincide with the slope of the second constraint, line CB, the 2 points C and B will be optimized. Any slight change beyond the defined range for C1 will result in new optimal solution being located at point B here or D. To calculate the range of change, we first fix the numerical value of the coefficient x2 and denote the coefficient of x1 as C1. This diagram illustrates that we can increase C1 till it reaches the second constraint line CB, or decrease it until it reaches the first constraint, which is CD. As a result, we can determine the minimum or maximum value of C1 by aligning the slope of Z with the slope of the first and second constraint. The slope of Z is equal to minus C1 divided by 2, while the slope of first and second constraint is minus 0.5 and minus 2. Respectively. Thus, we can find the minimum value of C1 using the following relationship, minimum and max. Likewise, the maximum value of C1 to maintain the optimality at point C can be calculated here. So, the range of allowable change for C1 to retain optimality in point C is between 1 and 4. When C1 is equal to 1, the optimal solution will be either point C or D. We have the multiple optimal solution. If the value of C1 decrease below 1, the optimal solution shift to point D. Similarly, it holds for C1 being equal or greater than 4. If C exceeds 4, if C1 exceeds 4, the optimal solution shift to point B. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.